Hello, I'm Tony. I'm going to show you my 450 watt Leslie that I made. It's driven externally by a PV 450 watt bass amp. Can you use bass for Leslie? Of course you can, and I prefer this one to the regular keyboard amp. It's got control here I don't use, another one here I don't use, which is the octave below. DDT I use for safety, and it's got a bright button here which is too bright for organ, so just leave it on normal, and plenty of EQ from the graphic sliders and the traditional bass and treble controls. It's got a mute button here, which you press it in, you still get a little bit of sound coming out, so you press it in, turn up the volume to hear the signal, we'll say, then somebody decides to press that back out, bang, you can get deafened by 300 or 400 watts. So let's have a look around the back. The power comes in there into the back of the amp, 8 ohms out into 8 ohms in there. So really you could use any old amp on top of the Leslie. Let's have a look inside the box. I'll just switch it off for safety. This is fiberglass insulation, roof insulation, same as sound insulation. See this curve here? This is skirting board. I made this little trolley out of skirting board, and it slips in there, and it's on wheels. The speaker is out of a KS100 Yamaha keyboard amp of the 1990s. The amp of which is in there. That's a cut down 722. I cut it down same size as a 145 without I took out the 9x6 speakers. The amp's in there, and the speakers here, it features a cast aluminium chassis rather than a pressed steel one, and a whacking great big heavy magnet, which does mean to say you can give it some stick and it'd take a little bit of punishment. The horn takes a tapping off this high pass filter made from polypropylene capacitors. I'm really pleased with this, much more efficient than the regular capacitors. In a way we're cheating, because the 8 ohms comes across there, and all of the frequency range goes through the 15-inch speaker, but it's only 450 watts into 4 ohms. This being 8 ohm speaker, it's 300 watts, which is still very loud, and this cabinet really goes well. This Leslie cuts through all the guitars and the drums. I've gigged it and it really cuts through. It's really loud. The horn driver, can you see that? Is a DC 100 15 ohms Celestian. It's 1960s, and I encased it in this 18mm ply, layers of, so that when the Leslie's on its side it doesn't fracture off at the throat. So this is bolted to the top there with 4 long bolts, because the magnet is quite heavy. The mains comes in here and goes to the two 12-volt relays, which I hacked out of a Yamaha organ. You don't need to remove the relays from the PCB, just scratch the tracks and expose the copper, and you can solder the connections to the copper tracks. There's the 2 suppressor capacitors across the relay contacts, and there's the regulated 12-volt DC supply. I got that off a television top box. That goes to the 12-volt side of the relays, and here are the motors: fast, common and slow. There is a motor. Look how small it is. I'll show you that in a minute. here is a DC-25 Celestian DC-25 horn driver with a 5/8 of an inch throat. I think the DC-100 has a 3/4 inch throat. You know, it's quite rare. And here's an American Eminence driver, a bit more modern, 8 ohms. I think it's got a plastic diaphragm, not titanium. I haven't tried that yet. So let's have a look at the motor again. It's a third or half or third the weight of regular Leslie motor out of a home Hammond organ. And has it got enough power to drive the horn and the drum? Does it go at the right speed? Of course it does. Works perfectly. There's only one problem. You have to modify it. And I'll show you what you have to do. Just there is a spring, right? And that spring used to be up there. You have to take it, stretch it, and put it down there by trial and error to support some of the weight of this rotor, some of the weight. So you have to stretch it by trial and error. And you buy longer bolts, cut them to length. That's a packing brass nut. That's packing aluminium and a little tiny washer. And you set it up on the bench to work in a vertical plane. It so happens I have one down here on the bench. Well, it's not quite a Hammond. It's out of a Kauai home organ with a real Leslie. Very similar to the Hammond, except this is 110 volts and these are 240. And the shaft here is a little bit different diameter to the Hammond, so you can't interchange the parts. There's a spring. Can you see that? You have to take it and put it down there. Take that spring, stretch it and put it down there by trial and error. Obviously you have to take out these bolts and make longer ones and pack them up and make it work in a vertical plane. The reason you have to do that is because in the home Hammond organ this is working in a horizontal plane and here we're working them in a vertical plane. So this spring assists this rotor retracting from this yoke in a horizontal plane. This spring assists the retraction of this rotor from this yoke in a horizontal plane. Now this spring assists the attraction of the rotor into this yoke in a vertical plane. So this yoke goes upwards due to the assistance of the spring and the electromagnetic force forcing it upwards, just engaging this shaft into that rubber pulley sufficiently such that it doesn't drag too much and take away too much power. It's a bit old-fashioned, but it works very well if you set it up properly. So we can now test the speed of the motors. It so happens I have a handheld foot switch. There we are. And you need a watch. And it's just, oh, that's very slow. I better switch it on. They're working now. Okay. So that's slow. Very slow and fast. Slow, center off, fast. I'll leave it on fast and you have to put your finger on the horn. Ooh. Right, and we're looking at about 7 a second. So I'm going to count 2 6s and 2 8s over 4 seconds because I can't count in 7s. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's about bang on 7 just about. We'll do it once more time. I can't count in sevens, and I'll do it over the 8 seconds. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, should count 9 on the last one. And it's going just about bang on 7, which is what you want really, 420 RPM. So we'll look at the drum. One, two, three, four, five, six, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Okay, well obviously I did that before because I knew it was going to go slower, and it's going at 3 6s and 1 8 over 4 seconds. So the average down there is 390 RPM. The average up here is about 420. So the motors have enough power to drive a wooden drum, and just there is the motor down below, set up just the same way as at the top in a vertical plane. And this is a wooden drum out of an English Sharma Leslie, so it's got good reflective properties, and the motor has enough power to drive that. It works very well. I say on stage it's got some stick, this Leslie. It cuts right through. In a way, there aren't many old Leslie and Hammond organs within 25 miles of my house, and this Leslie is a little bit of a hodgepodge. It's got a Yamaha speaker, my own high pass filter, Yamaha relays, a Celestian horn, a Sharma drum. It's got Hammond home organ motors, my own 9mm cabinet, and a beautiful 450 watt PV bass amp, and it goes like stink. So there's my Leslie 145, as I call it. Cut out the louvers as well, and the sound really comes out nice now. And there's the amp. There's my Yamaha MIDI bass pedals. There's my Hammond B3, as I call it, made from 2 Hammond XM1 modules of 1996 era. It's lightweight. It's on wheels. I'm very pleased with that. And there again is my garden and my high-powered, lightweight 450 watt Leslie.